Albert Einstein said that there are only two ways of looking at the universe. One, that nothing's a miracle, or two, that everything is a miracle. And if you know much about him and his personality, he probably went with that everything's a miracle sort of a thing. And I don't care what you think about how the universe got here, you know, the Big Bang, or whether God said, let there be light, or both. You believe in miracles. Every single person does. And there's no way to get around it. However you think the universe got here, you believe in something that's fantastical and unimaginable and doesn't happen today. Unless you're a steady-state theorist, you know, but that's something else. And so everybody does believe in miracles. It's just a matter of what miracles you choose to believe in. It took me 5 hours, but I did convince the Atheist Club at University of Texas El Paso that they believed in miracles too. They finally admitted, yes, we do, you're right. Tonight we're going to be talking about stellar evolution. We're not talking about the Big Bang, we're talking about something that happens after the Big Bang and is in the course of that kind of thinking that the universe made itself out of nothing, violating the first law of thermodynamics, that all the matter and energy in the universe was created at one point in about a trillionth of a second. Well, I'm going to get ahead of myself. Marilyn Vosavant here is in the Guinness Book of World Records as having the highest IQ, and I kind of like quoting things from her. I don't agree with everything that she says, but I like her philosophical statements. Look what she says here. Be able to defend your arguments in a rational way. Otherwise, all you have is a what? I taught high school for 11 years, so I do fill in the blank questions. An opinion. You know, there's nothing wrong with having an opinion. That's fine. But you know, my opinion doesn't make it so. I found out today that they found out that many of the clades of dinosaurian reptiles started going extinct long before that meteorite hit the Earth. And about 8 years ago, all the paleontologists in the world got together and voted that it was a meteor. That's it. Let's stop all these other 30 theories that exist on the extinction of the dinosaurs, and they all got together and voted. Remember when we voted Pluto out of the solar system? Yep, all astronomers in the world got together. Probably Percival Lowell was wrong in 1930, and Pluto always was a planetoid. Just look at the elliptical orbit, and it's so inclined. It's different. It's probably just a planet. But us getting together and thinking about it and arguing about it, and it's almost like two people arguing on a park bench, that they think that the nature of the universe shifts back and forth depending on who's winning the puny argument. Do you think Pluto cares what we think? No, it just goes along being whatever Pluto is. And you know what? If you're trying to prove how the universe got here, you're too late. You're too late. It already happened. It is never, ever. It's a sin in science to make it the job of science to prove that you're right. As a matter of fact, we're supposed to try to prove the null hypothesis now, aren't we? You see, you're not supposed to try to prove what's right, that you're right. You're supposed to find out what's true. That's it. That's the only important thing in science. It's why I got into science. I said that during a debate between me and 3 biology evolution professors at in Greencastle, Indiana, at DePaul University, and they all 3 just about fell out of their seat because I said science was a search for the truth. They went, no, 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 and one of them spoke and said, it's not a search for the truth, it's a discussion. Like that was smart. I'm sorry. I got into science to find out how things work, how the world works, how the universe is, how things do what they do and got here. And the only thing that matters is the truth in science. Our other things are fun and interesting. That's okay. It's kind of cool to have great ideas for heuristic value or just fun thinking. Opinions, look, without opinion, without imagination, you know, Einstein was very big on imagination too, we would never advance. But after all of our stories are done, at the end of the day, Louis Pasteur said, do not put forth anything that cannot be proven by experimentation. Without observations and the scientific method, we just have opinions, and that's okay. But don't tell people that if you don't have my opinion, you must be wrong, or you must be stupid, or you must be against science. I can't tell you how many times, as a biblical young earth creationist, a scientist with 4.5 degrees, I do have 4.5, that I've been told I'm against science. I love science. Science is my entire life's work. I just have a different scientific position than most of the people in science. But, well, There was a time when if I didn't believe in the phlogiston theory, or maybe even flat Earth, certainly if I didn't believe in geocentrism, I'd have been in the minority too. So I don't mind being in the minority, but I'm in a thinking minority. I can't prove everything that I say is true, but neither can other people. But the majority gets to write the textbooks, I guess. Let's go on. Okay, let's take a look here. Now we're going to talk about stellar evolution today. Stellar evolution. And stars are categorized according to their luminosity and their color, their brightness and their color. And we, through the entire electromagnetic spectrum of the visible anyway, we classify stars as type O, B, A, F, G, K, and M. And we memorize that by saying, "Oh, be a fine girl, kiss me." Or if you're a girl, you say, "Oh, be a fine guy, kiss me." And that's the way all astronomers remember this. But if you actually plot, and this is called a Hertzsprung-Russell diagram or an HR diagram, if you plot the luminosity of the star versus its color index, you actually get sort of a curve, a significant curve, and this is called the main sequence. And we call these main sequence stars. Now that's observations and calculations, and it's manipulating of the data into various ways of presenting it. But then somebody decided, okay, that means that the blue ones are the young stars and the red ones are the old stars, and then they lined it all up in this thing about the life story of a star, when maybe the red stars started out red, and the blue stars are never going to turn red. You know, so they turned it into a stellar evolution story, much like all those fossils they dig up, monkeys and people, and try to call them monkey people. That's next hour. I'll show you that. That's a lot of fun too. Now they've taken the data and made up a story about it. The only thing that you really can get is what the data says. Now let's take a look at the story then of stellar evolution. The Hertzsprung-Russell diagram is real, but does it say that stars evolve? Let's take a look. How many have ever heard of the Drake equation? The Drake equation, you know, that predicts, calculates the number of intelligent civilizations that should be in our galaxy. And it has all of these 1, 2, 3, 4, 5, 6, 7, 8. Wait a minute, 1, 2, 3, 5, 6. I thought it was 7. No, it is 8. 8 different factors involved. Every single one of them is a guess. Every single one of them is a guess, and they multiply them all and put an equal sign next to it, and suddenly, ta-da, it's not a guess anymore. You know, I don't mind the Drake equation. Drake himself said that the actual number of intelligent civilizations, advanced civilizations in our galaxy is somewhere between 1 and 1 million. Why didn't he say 0 to 1 million? He assumes us, so we've actually got data. We have a data point for that one. So he can say 1 or more. Yeah. But he even says 1 to 1 million. All the rest of these things are guesses. And there's nothing wrong with guessing. It was Carl Sagan that said the life expectancy for a civilization once they invent radio technology is 200 years. After that, they'll blow themselves up in a nuclear war. So we only have a 200-year shot at making contact with any of these civilizations, and somehow we better, you know, hear from them. I guess they could only be within 200 light years. Well, okay, that's another topic. But this R here is the rate of star formation in our galaxy. And that's what this topic is tonight, stellar formation. Can stars make themselves? Now, I'm a biblical young earth creationist. Of course, I think God made the stars. And I think that's not unscientific, because if God actually did make the stars, then that would actually be a scientific fact. And to eliminate God from the equation when you don't know is irrational thinking. I mean, you can say, I don't like the idea of there being a supreme being. Fine, you can say that. But you can't just throw out the variable just because you think that. Well, anyway, there are all these variables here, and does this prove that there is 1 to 1 million civilizations? No, it just proves that there's one. And Drake didn't say he knew, but people took this and ran with it tremendously. Okay, let's take a look at this basic chart of the Big Bang. That's the Wilkerson microwave anisotropic probe. And they got this map of the universe that then was interpreted as time zones of the history of the universe. Quantum fluctuation creates the entire universe, including space, time, matter, and energy, and there wasn't any of those, and then all of a sudden there was because of a quantum fluctuation. And then the inflationary period expands it all, where space actually stretched out at faster than the speed of light, and maybe a trillionth of a second, you've got the universe as the size of an orange, and then bang, it goes the rest of the way. And then all the light from the Big Bang explosion, the energy dies down, and you have gas clouds, an afterglow pattern. A lot of people say, well, that could be where God said, let there be light. There are some similarities in the two stories, okay? But what does the data actually say? What do we actually see? And then, in the story, you have 400 million years, while all that bright, glowing gas clouds went dark, and then had to collect by gravity into new stars that had never existed before. There weren't stars before that. The first stars form after 400 million years of gas clouds collecting by gravity, and then we're off and running to 13.7 billion years later. So this is called the Dark Ages. But how did the universe get out of the Dark Ages is what we're talking about tonight. Here's a cover of Discover magazine, and this is, let's see, I think I got the year there. Yes, 2002. The day the universe lit up. Scientists uncover the second creation, 100 million years after the Big Bang. And then on the cover, they got a picture of a nebula there, a modern star factory in the Large Magellanic Cloud. Okay, a modern star factory. Well, this is interesting. How do clouds of gas make stars? I want to bring this up. I like Nikola Tesla. He said, today's scientists have substituted mathematics for experiments. And they wander off through equation after equation and eventually build a structure which has no relation to reality. Tesla, invented remote control devices in 1893. Not that there was much to remote control, but the guy was a little ahead of his time. And, yeah, mathematical constructs that become complex, nested within nested equations until they're off and running, and you've got the universe making itself because you calculated it so. Equal signs don't always tell the truth, just because you draw one, like in the Drake equation. Okay, this is a standard textbook, Prentice Hall, a high school textbook on earth science. A nebula is a large amount of gas and dust spread out in an immense volume. That's true. You see them through telescopes. All stars begin their lives as parts of a nebula. And how do we know that? Gravity can pull some of the gas and dust in the nebula together. The interacting cloud is then called a protostar. Okay, now we're telling a story because no one has ever seen this happen. It's a story. I'm not saying it's a stupid story or a bad story, even a wrong story. But it is a story. It's so much less than a theory, as you'll see, because we actually know scientific fact, laws, and principles go against this being possible. Gravity cannot do this. We'll see why. A star is born when the contracting gas and dust become so hot that nuclear fusion starts. Now, most people don't realize, we got some biochem majors here, maybe they know. We got three of you. Well, okay, biological sciences there. Aurora, yes. The first original nuclear bomb was an atomic bomb, a fission bomb. Now, later we got the thermonuclear bombs, the hydrogen bombs, which were fusion bombs, 200 to 500 times stronger than the bombs at Hiroshima and Nagasaki. These are fusion reactions. To get a good fusion reaction going, you got to heat it up to about 1,000,000 degrees. 1,000,000 degrees, maybe 100,000 would do, but 1,000,000 degrees. The only thing that we knew at the time that could do that was a fission bomb. The fuse on a fusion bomb, on a thermonuclear bomb, is a fission bomb. You have to use an A bomb to get an H bomb hot enough to go off. That's pretty hot. So how hot does the gas and dust have to be? At least 100,000 degrees, probably 1,000,000 degrees to ignite nuclear fusion chain reactions. Is this statement based on science or based on belief? Well, have we ever seen this happen? No. We do know from our own experiments here on Earth the temperatures that are capable of igniting helium. We even use deuterium and tritium, but just how about just regular hydrogen, protium? How could we get those things to actually start the fusion? What would the temperature and pressure need to be? Well, the temperature's coming from gravity pulling the gas cloud together. The contracting gas will heat up. Now this is just chemistry 101. This is Charles's law of pressure and temperature. When a gas is squeezed, it gets hotter. When a gas is released, it gets colder. That's how your air conditioner works and your refrigerator works. But when you squeeze a gas, it gets hotter. But hot gases, do they want to continue contracting, or do hot gases want to expand? They want to expand. That's, again, that's Charles's law. That's the combined gas law when you put Charles and Boyle together and you get the ideal gas equation, that hot gases expand. And it turns out that expansion is much, much greater than the force of gravity. Gravity is the weakest of the 4 known forces of the universe. Next to it being electromagnetic force, and then gravity is the weakest. I mean, come on. For gravity to have enough to do this, you need a solid rock 8,000 miles thick. And that little probe that landed on that asteroid, it bounced, you know, and it had to bounce 3 times before it would finally stick to the asteroid by gravity, because the asteroid's gravity was so low. You need huge masses to get even a teeny bit of measurable or meaningful gravity. Actually, although I know that you two are just friends, gravitationally you are attracted to each other. Just a little teeny bit, because those 2 masses aren't that great, not compared to a whole planet. Okay, so I'm saying that this is based on belief, which again is okay. It's okay to have the belief that somehow the laws of science are circumvented by some new principle we've never discovered yet, and we've never seen it actually do its thing, but we want to believe it anyway. There's nothing wrong with belief, just don't teach it like it's a fact and we got it down, because we don't. Nobody does. Let's take a look. Again, Marilyn Beausavant, one of my favorite people, says, we must be careful not to teach theories as a fact. It slows scientific progress immeasurably. She has that article, Ask Marilyn, in Parade magazine. Okay, heated gases want to expand. Stellar evolution can't be real, because gravity can't contract a cloud of space gas into a star against its pressure to expand when it gets hot. I mean, if you got to get it up to 1,000,000 degrees, that's a lot of expanding force compared to the gravity force of lone hydrogen and helium and lithium atoms floating around loose in space. We're talking about atoms that have electron clouds, that have electrons orbiting them. They're not already 1,000,000 degrees. They're floating around in the dead cold of space. And gravity gets them together. Yes, they would heat up. But as soon as they get to a certain trying to get it together, then they would expand back out. It would never be able to come together into a proto-star like the theory says. Contracting gas heats up and heated gases expand with a force at least 100 times as strong as the force of gravity. So it can never do this. If the stellar nursery idea is true, why don't we ever see fusion ignition of stars flickering to life in the Orion Nebula, or the Eagle Nebula, or the Trifid Star Nursery, or all these other gas clouds, these nebulae that are candidate spots in the universe for clouds of gases in space to go ahead and contract and make protostars? We've never ever seen it happen. Now, I had one person say to me, it was near Huntington, West Virginia, Marshall University, said, well, Dr. Jackson, you don't understand. A star would gradually get brighter and brighter and brighter. It would take, 1,000,000 years or something, so you're never going to see that. And I said, no, sir. No, sir. That's not how chain reactions work. This is the exact same chemical reaction. Well, nuclear reaction happens in a fusion bomb, and a thermonuclear bomb. It's a chain reaction. We should have all these star maps of the sky. We do this with asteroids and comets and meteors that we're trying to track through the sky. We know what's supposed to be in the sky every night. We look at it again the next night. We have computers doing this sort of thing, and then we got Jill Tarter with SETI, she's looking for all these kind of things too, in case it's, you know, the mothership from Stargate or something coming after us. We should know there's no star in that spot, and the next night there's a star there. It would, because of the nature of fusion reactions, which is a chain reaction, it should be there the next night. It's not just going to gradually, it's going to go, and it's going to be if this could happen, if it was a chain reaction, a fusion reaction, it would do it that way. We never, ever, ever have seen a star flicker to life. We've seen plenty of them explode, supernova stars explode, and we know, we have actually got hypothesized nuclear processes that actually make sense, based on what we actually know, to tell the mechanics of how supernova happens. But the whole thing about how the supernova star, before it exploded, got there in the first place, come on in. If this is the stellar evolution and human evolution talk, yeah. We should actually see these things coming to life as quickly as we see them being destroyed. I know a supernova would be a whole lot easier to spot. We can see those over in other galaxies. And I'll show you a picture in a little bit. But okay, just to regroup here, you got a nebula. The popular theory says that stars form from vast clouds of gas and dust through a gravitational contraction. But as soon as they try to contract, they'll get hot and then they'll want to expand back out again. So they'll never, ever be able to coalesce into anything. Because of this, I'm just going to say, Physics 101, Chemistry 101, that stellar evolution doesn't qualify as a theory. There are no known principles of science that permit this to happen, and there are known principles of science that say it can never happen. Now maybe there's some new force in the universe that we haven't discovered yet. That's fine, I'll allow that. But at this point, it barely qualifies as a hypothesis. A hypothesis is supposed to be educated, what?
Guess.
An educated guess. Educated says this can't happen. Now, hey, we haven't discovered the star-forming principle yet. But educated means, as far as everybody knows, this can't happen. It's impossible by the laws of nature, just like the Big Bang violates the first law of thermodynamics, and the second law of thermodynamics, and many other problems with it too, but this goes along with it in the larger Big Bang story. In a massive, dense cloud shielded by dust, it is believed, it says here, 1994, that collapse can be triggered when the cloud is slowed on passing through the spiral density wave pattern of our galaxy. The spiral density wave theory talks about how our galaxy can maintain the spiral arms, sort of a propeller blade twisted octopus arm thing that we have on the arms of our galaxy, the Milky Way. Well, again, it's believed, it's possible, it could happen, and that's fine to say that, but then everyone goes, no, but this is true. You can't make that jump. That's not science. It's cool, it's interesting thinking, but it isn't science till you have evidence. I have students asking me, is the Loch Ness Monster real? And I said, well, until we catch one and put it in an aquarium, we don't really know. Are aliens real? Well, there's not a single data point that says that there's intelligent life on any other planet besides ours. Nothing that's confirmable scientifically. It's a cool, interesting story. Hey, I like Star Trek. I like the idea of Klingons and Vulcans warping around the universe. That sounds fun to me. A galaxy far, far away and all of that. But it isn't science until we have data and observations and the scientific method. Okay, the Eagle Nebula, I've even seen t-shirts made of this showing that's how the molecules of life got started, because the stars in there through fusion reactions made the heavier elements that ended up being the elements of life, like carbon, nitrogen, oxygen, phosphorus, and sulfur. Do pictures confirm that stars are forming? No, we don't. Actually, we see stars floating around out there, but have we ever seen one actually, spark to life in any of the nebulae? No, not at all. Sometimes this is called the Towers of Life. That's also part of the Eagle Nebula there. You see the eagle flying there. 1998. Stars are still forming today. About 1,500 light years away lies the Orion Nebula, enough gas and dust to make millions of stars. It even contains protostars that are still condensing. Again, we don't see protostars We see maybe blue stars, which they say are young stars, but we actually don't see gas clouds that are contracting. They're just so sold on the theory, they figure we're going to prove it eventually, let's just go ahead and put it in print. It's a little, like Mark Twain said, the rumors of my death have been greatly exaggerated. Well, the rumors of star birth have been greatly exaggerated. There's the Orion Nebula there that we're talking about. It is a beautiful gas cloud in the constellation of Orion. I think it's in one of the stars in his dagger sheath. But how do we know that stars are actually being created there? The story says so, but that's not science yet. It's a posit at best. Images taken by the Very Large Telescope, that again, the Horsehead Nebula. We're supposed to be thinking that all nebulae have stars forming in them. Stars, a lot of these nebulae are actually expanding. A lot of them could be formed by, well, like the Crab Nebula, formed by supernova stars that exploded, so those gases are still receding away from the center. The Trifid Star Nursery, it's even called. This is where stars are supposed to be born. It's a story, and I don't mind a story, but don't go around saying you're stupid if you don't believe the story. Well, you might be going against the majority's personal beliefs, but I'm really only sold on science. I'm only sold on science, and science is knowledge. If you do something in good conscience, you do it with knowledge. Chili con carne is chili with meat. Okay, con means with, like conduct, to go with. And science means knowledge. La ciencia, science. In German, Wissenschaft, which means knowing craft. Knowing craft. You see, science, the word science just means knowledge. It doesn't, it can be full of philosophy. It can be full of ideas, yes. But when you actually make your list at the end of the day of what works and doesn't, what equations function and help us build suspension bridges and computers and space shuttles, that's the part that actually we know works. Theoretical science is fun, but we can't be dogmatic about things like that. And I find dogmatism in stellar evolution theory. 1976. There is general belief that stars are forming by gravitational collapse. In spite of vigorous efforts, no one has yet found any observational indication of confirmation. Thus, the generally accepted theory of stellar formation may be one of 100 unsupported dogmas which constitute a large part of present-day astrophysics. Now that's an old quote, but I got one from the 2000s. We'll get to that too. I'm just showing you there's a big long history of people saying, that's our theory, but we really have never seen it, and we really don't know how it could even work. Let's just keep working on it. Precisely how a section of interstellar cloud collapses gravitationally into a star is still a challenging theoretical problem. Astronomers have yet to find an interstellar cloud in the actual process of collapse. And this is one from 1990, Science magazine, and Lada is a well-known astrophysicist. Most disturbing, however, is the fact that despite numerous efforts, we have yet to directly observe the process of stellar formation. We have not yet been able to unambiguously detect the collapse of a molecular cloud core or the infall of circumstellar material into an embryonic star. Until such an observation is made, it would probably be prudent to regard our current hypotheses and theoretical scenarios with some degree of suspicion. Now, I realize I'm not proving that stellar evolution theory isn't true. I'm just proving it's not a qualified theory yet. Hey, it might be true. But the science doesn't support it, and the science we do know about says it's impossible. The science we already know says it can't happen, and we've also never observed it happening. No mechanism exists to condense gaseous clouds into ignition, to get hot enough to ignite a thermonuclear reaction. Despite high number of stars, no one's ever seen a star be born. Why don't textbooks state known problems with stellar formation? Why don't they just say, instead of dogmatically rolling this out for kids, we're going to have to rewrite the textbooks. We've had to do it before, but we're going to have to do it again. In the past 100 years, we've had so many theoretical things, and what bothers me about the industry of science now, the enterprise of science, is that someone gets a cool idea and writes a paper and maybe gets an endowed chairmanship or something, or tenure, and now everyone hails them as right. That's right. It was only, what, about a year and a half ago that Alan Guth and Andre Linde almost got a Nobel Prize. I mean, man, we thought we found the gravity waves that they predicted would have been the aftermath of the Big Bang. The gravity waves would be the aftermath of the Big Bang. And I saw a little video, you know, on YouTube, whatever, about these graduate students coming up to Alan Guth's house, knocking on the door and saying, Dr. Guth, we found it. We found the gravity waves at the edge of the universe that are the remnants left over from the Big Bang. And he's all excited. They're talking Nobel Prize. We're talking Nobel Prize. And then a couple of months later, if you kept reading the news flashes, it was actually dust clouds. They had misread some dust clouds out in deep space. You know, which is okay, but it shows me they're a little trigger happy, a little jump the gun, a little on the gun about this. Now, just a couple of months ago, there was a probe that has been quietly circling the Earth for like 15 years with these gyroscopes and have actually, finally proved, scientifically, by observations and calculations, gravity waves are real. But the gravity waves are being generated by our planet. Those are the ones we found, not ones that are left over from the Big Bang. So for the first time, and Einstein, like he predicted, you know, the bending of starlight and many other things, time dilation, all that, Einstein sort of inferred that gravity waves would be real. And now we actually, just a couple months ago, found out they really are. But you didn't hear much about that because it didn't help prove the Big Bang, you know, but it is out there. That's a new discovery. Now, whether gravity waves are actually contain graviton particles or not, those are hypothetical. And are forces actually made of particles? I mean, light, the wave nature versus the particle nature of light. What is a photon actually? Still, people argue about that and do equations and stuff. But is the force of gravity actually due to particles of gravitons? And gravitons are hypothetical particles, totally. They're like dark matter. They even have said, talked about anti-gravitons, when we don't even know that gravitons in normal matter exist. So that's okay. Scientists need imagination to roll out scenarios that we can work with. Einstein called them thought experiments. And then there's, of course, all these different kinds of imaginations. It's important. But teaching it dogmatically is not science. It's some kind of a fanatical cult sort of religion, and it's not science at all. I have strong, obvious opinions about that. Okay, here's a picture of a galaxy, NGC 4725. One night there's nothing there, and the next night there's a supernova star exploding. So we can see, I realize supernova stars would be a lot brighter than little baby stars starting out. But we are watching the sky all the time for new events, like what astronomers do. That's how they discover new meteors coming close to us and things like that. Well, let's just look at a little bit of statistics. If we have 100 billion galaxies, and even the Hubble Deep Field didn't get that, didn't get to the end of the universe, so we don't know, there's probably more than that. That would be about 200 billion stars per galaxy. If we just, these I know are not exact figures, they're ballpark. If the universe is 20 billion years old, that's a little higher than many say. But, this would work out that there should be 100 trillion stars being born per year. If you work it out, 2 billion stars per day, 31,700 stars all over the whole universe per second. Surely one of those at some time get close enough for us to see it light up, and we can see this. And don't get me wrong. It's not that this is escaping us. Scientists are looking for this. Astronomers are looking. Hey, you're going to be famous if you're the first one to see this happen. So you better bet they're looking. Mount Palomar's looking. These people are looking and trying to detect these with radio telescopes and with optical telescopes. That guy Lada, yes, that's from that same article. Despite numerous efforts, we've yet to directly observe the process. the origin of stars represents one of the fundamental unsolved problems of contemporary astrophysics. And if you're sold on stellar evolution, then this is considered an unsolved problem. Unless you have another star formation theory that doesn't involve gravitational collapse, then maybe you wouldn't say it's an unsolved problem. It's an unsolved problem for gravitational collapse star theory. That's the only thing it's unsolved for. Maybe it'll never be solved. Maybe it never did happen. And that's probably the way the books should present it. This is the edge of our knowledge. We don't know. When the movie Jurassic Park came out, I was actually teaching science enrichment classes for little second graders, and these kids all came in with little Jurassic Park t-shirts on and everything. I went to see the movie, and I was stunned their parents would let them go see that. Man, I couldn't get the images out of my mind. It didn't scare me, but that was the best, at the time, it was the best special effects. But later, when I was teaching biology at the community college, students would ask me, could Jurassic Park be real? Could we do that? And that's what's great about Michael Crichton is, and any good sci-fi author, they will take what we can do and go up right to the edge of that and jump a little further to stimulate our imagination. Can we do warp drive? Can we clone dinosaurs? You know, can we do time travel and all those kinds of things? And that's what good sci-fi is. But we could discover how to clone dinosaurs next year, 100 years, or maybe it's not possible at all in the known universe. It just might not be possible. But it makes good imagination and thinking, and it spurs on a lot of other kinds of thoughts. Well, this is Eric Lerner, president of Lawrenceville Plasma Physics. He wrote this book, The Big Bang Never Happened. I think that Lerner is a cosmic string theorist, and so he's not in favor of the Big Bang. And he wrote an open letter to Science, New Scientist magazine in 2004 called Bucking the Big Bang. At the time, he had 33 other scientists from 10 countries sign it. A couple years later, I read the list of scientists that had signed this protest against Big Bang being dogmatic. And my old astronomy professor from George Mason University, Minos Kafatos, was on that list. Now, I knew that Dr. Kafatos believed in the Big Bang Theory. What he was against was that it was being taught dogmatically. Our ideas about the history of the universe are dominated by Big Bang Theory, but its dominant rests more on funding decisions than on the scientific method, according to Eric Lerner and dozens of other scientists. Okay, this is one thing from the article that he said. So, discordant data on redshifts, lithium and helium abundances, and galaxy distribution, among other topics, are ignored or ridiculed in favor of just keeping on believing in the Big Bang Theory. The Big Bang model provides only hydrogen, helium, and small amounts of lithium being formed at the beginning of the Big Bang. No heavier atoms, kinds of elements, would have been formed. So population 3 stars, the old ones, the original ones, should contain only hydrogen, helium, and traces of lithium, because no stars had been around at their time to make the heavier elements that could have gotten globbed into their dust clouds that made them. No population 3 stars have ever been found. All stars we've ever done spectral analysis on for the elements that are in the star, absorption spectra and emission spectra, all stars have trace amounts of heavier isotopes in there. There are no population 3 stars that have ever been. That does not mean they're not out there, but we have been able to take the spectral analysis of many, many different stars, and none of them have just hydrogen, helium, and lithium. They have trace amounts of heavier isotopes in there too. The truth is, we don't understand star formation at a fundamental level. So why do so many textbooks say that we know how stars form? I think that is a problem in science and in science education. I think science education, because that's what my doctorate is in. I've trained, 700 teachers have I trained to teach science. That's what I have. Over 6 years, I trained over 700 people how to be science teachers, and I think the most valuable thing is independent thinking, curiosity, critical thinking skills, and thinking is very, very important in science, and it ought to be. That's how we generate new hypotheses. That's how we evaluate old hypotheses. don't forget, for the Ptolemaic system with the Earth in the center reigned for 1,000 years until people like Copernicus and Newton and Galileo and Tycho Brahe and Johannes Kepler, his apprentice, finally set to rest this Earth in the center thing forever. And now it's not taught in the universities as it was for so long. Okay, now it's time for a Calvin Hobbes because I strained your brain. Now let's relax a little bit.
I don't understand this. Not a single part of my horoscope came true. My policies weren't implemented and circumstances didn't turn in my favor. Just the opposite, in fact. What went wrong? I thought this stuff was based on planets and stars. How could those be misread? What kind of science is this?
Well, I'm sure any scientist would give you a categorical answer.
Maybe tomorrow's horoscope will run a correction and apology.
I do think that selling theories as facts, even theories that we know in our current state of knowledge can't be true, and we're just hoping some breakthrough will say it could be true because we like the theory. Big Bang Theory was in trouble for a long time, and cosmic string theory was really taken over. And it even showed up in popular literature. I mean, the Starship Enterprise was always running into a cosmic string, right? Or a vortex or something like that. And it was always string, string, string. Then the infrared astronomical satellite, the IRAS satellite, actually found a thermal ripple at the edge of the universe, which could have been there 100 different ways, but one of the ways could have been if the Big Bang was true. So they jumped on that, said the Big Bang's true, and then the Big Bang got a shot in the arm, and it's been coasting on that ever since the 1990s, mid-90s. And then trying to talk about the gravity waves, which didn't turn out to be true, and the Wilkerson microwave anisotropic probe did do a density map of the universe. We have a heat map of the universe. There is a superstructure to the cosmology, the universe's structure, which could be there in many different ways. It could be there that way if the Big Bang was true too. But this is not a presentation on the Big Bang. There are 7 violations of laws of science for the Big Bang. I'm just trying to talk about stars. Albert Einstein also said, I want to know how God created the world. I'm not interested in this or that phenomenon, in the spectrum of this or that element. I want to know his thoughts. The rest are details. And whether you believe in God or not, how the world got here should be the real thing you're looking for in science. It doesn't matter what could have happened. I'm sorry, that's interesting. What could have happened, or what would have happened, or what should have happened. I'm sorry, but in science and in history, the only thing at the end of the day that's going to matter and should matter is what did happen. I'm sorry, my wife would hate my grammar. She is a middle school special ed language arts teacher, and she's kind of a grammar Nazi. Good thing Bonnie's not here with me, yes. But what did happen is all that matters. Linus Pauling, who won 2 Nobel Prizes, he was wrong about the triple helix. He thought the DNA molecule was going to be a triple helix. That's okay. He got a Nobel Prize for discovering in 1932 the principle of electronegativity. And then he won the Nobel Peace Prize in the early 1960s for being a famous scientist against the proliferation of nuclear weapons during the Cold War. But Linus Pauling said, science is the search for the truth, the effort to understand the world. He said that in an article he wrote called No More War. And there is my contact information there. And I think, when do we start I know we got a little time for question and answer and discussion, but when are we supposed to start, Mr. Kisner, the next thing? Okay. Well, people can take a little bathroom and water drinking breaks, and we can also, in the next half an hour, do some Q&A too. Now, it could be any questions that you might have about anything that you've ever wondered that maybe I can help with or answer, or that other people in the audience can contribute to, or certainly anything about anything that I said here today. Yes, Sally.
Concerning the nebula, we call them dust clouds. What is it exactly that we're looking at there? What physical material are these dust clouds made out of?
Please repeat the question because there's no microphone.
What Sal asked was, what are the nebula, what are these dust clouds made of? And there are all these different colors and things. A lot of times, it's kind of like if you had a bunch of colored colored tissue paper, and as a Halloween decoration, and you put a light bulb inside it. Often the stars inside the nebula will light up this gas cloud. And the gas cloud is actually made of different kinds of particles. The dust, cosmic dust, just chunks of matter which either were created by God in place or by the steady state or whatever created everything in the universe, or came out of exploding supernova stars. It could be just loose atoms of all different kinds. But mostly these clouds are made out of hydrogen and helium. Hydrogen is the most prevalent element in the universe. It's also the smallest of all the elements. So hydrogen, helium, and lithium, and some other kinds of things floating around out there. Even chemical reactions that have occurred with heavier elements that have made simple sugars and even some amino acids and things like that floating around out in space, along with many other different random molecules. So that's what the clouds would be made of. The reason they shine is not because they are actually giving off light. Normally there's some stars inside it that are lighting it up from the inside, kind of like a Halloween pumpkin. Does that help Sal? Okay. Yes, Casey.
You were explaining earlier how hot expanding gas cannot be overcome by the forces of gravity to collapse on itself. I was wondering what your opinion is on how stars stay together in the first place if they're hot burning gas.
Okay.
How do they not just expand?
Yeah, they actually do expand, and
Repeat the question. Repeat the question.
Oh, I'm sorry, the question. If gas clouds can't contract to create a star, then why don't stars, when they are so hot, why don't they just fly apart? Our star, the sun, has gravity that's 25 times stronger than Earth's gravity. And once a star is actually together, for gravity to collect a bunch of particles together against their will into a ball like that, and they have to get up to 1,000,000 degrees, along the way, they're going to get hot enough to want to expand back out, so they can never do it. But if the star was actually either made by God or made by some other process that isn't a part of standard Hertzsprung-Russell diagram, stellar evolution, OBA, fine girl, kiss me, if it isn't that story, if a star actually was formed in place at that size, at that density, at that mass, and with thermonuclear reactions already happening, it could hold together, obviously, because our star does. The gravitational attraction is strong enough. Now, the sun is constantly blowing off its mass. We call that the solar wind. It is expanding out, but the main body of our star has enough gravity to hold itself there. Now, it's outgassing constantly, and any star would, but it's also doing fusion reactions that are causing the core to be made of heavier and heavier elements, hydrogen, then helium, then carbon, all the way up to iron. So, and at that point, we do think a star would go supernova. So we do think that's the mechanism of a supernova star exploding. So if it was actually created in place, like if our moon was created in place orbiting around the Earth, then a lot of the problems we have about how the moon get there and how does this work are solved. If the star somehow was created either by God or some process that isn't the standard stellar evolution, if it could be there the way it is now, it would work. But coming together by itself, by processes we're thinking of now. Does that answer your question?
Sort of. I mean, the way I'm thinking about it is kind of like the nucleus, how the protons in the nucleus of an atom, they have positive forces, so obviously they're going to want to expand anyway, but the strong nuclear force is what keeps it together. So you can actually overcome the barrier of the positive forces if you have enough of a strong nuclear force. So the Jeans condition is basically the equivalent law to which gravity can pull all the mass of the gas together into a star. If it doesn't have enough mass, obviously the expansion of the gas is going to exceed what is needed to pull it into a star. But at a critical point of enough mass, mathematically it works out that you could collapse gas into a star.
The strong force is thought, the proton-proton force, is thought to only be able to take effect at very close range, not across long ranges. even van der Waals forces in between, interactions between the nucleus of one atom and the other atom. At these temperatures, you aren't actually going to have electrons, well, in a neutron star, you'd have the electrons thrown out of orbit. You should have a plasma, a lot of loose flowing around electrons in any thermonuclear reaction. But the strong force and various colors of the neutron-neutron force, the proton-neutron, the neutron-proton force, and all of that would only take place at close proximity. Now, if the particles are actually moving as fast as they have to move to sustain a nuclear fusion reaction, it'd be like if I shot two bullets that were both made out of magnet by each other, they're going too fast for the attractive force to catch them. There's a lot of particle movement, so that would have to be a mathematical construct. Do we actually see that happening?
Well, it is a mathematical construct. It's the Jeans condition is what they use to quantify the point at which the gas would collapse into a star.
Okay.
The forces of gas expansion is going to be greatest when it's actually compressed into a star. It's not like you'd have greater gas expansion when it's not a star yet.
Why not?
That doesn't make any sense.
Why not?
Because as you're compressing and heating up gas, the pressure expanding outward is getting higher and higher.
Before the star
holds together.
Before the protostar heats up, you are going to have electron clouds. In the sun right now, you don't have electron clouds in the atoms. But before the gases start coming together, you are going to have electron clouds. You aren't going to have any strong force between any of the atoms. It's just going to be non-nuclear physics and chemistry, yes?
Right, I was just using that as a comparison. I'm not
A
saying
comparison of what?
To the theory that a gas, if it's there's a force that can, the force of gravity can at some point overcome the expansive force.
Well, how could it if it's weaker?
It's not like a straight line. So as you get more and more mass, there's a critical point where the mass of the gravity, even though it's a weaker force one-to-one, will overcome the force of expanding gas.
Well, the entire nebula has the exact same gravity when it's huge as it does when it's small. It's just that the gravity is focused in one spot. So the actual amount of gravity is the same because gravity is like inertia is a property of matter.
Right, but as you get more and more mass building up in a specific area and you start getting the protosynthesis in the middle, you're going to have a central point for the gas to collapse on you.
And this is due to the strong force?
No, it's not due to the strong force.
Oh.
That was simply a comparison. The strong force,
Gravity.
the strong force is a stronger.
It's of the four forces, it's the strongest.
Right, but you have to be in close proximity
Yes.
to overcome it, right? So you have
No, you have to be in close proximity for it to take effect.
Exactly.
We even think that if things get closer than that, they repel. And if things get a little further than that, they attract. That's the only... Now, okay, something you have to understand about the strong force and the weak force. You're right, protons should fly away from each other because likes repel and opposites. It's another fill in the blank to keep you awake there. Come on, Turner, give it to me. Here we go. Yeah, opposites attract. So we knew there was a force holding the protons together because we already knew electromotive force should make them fly apart. Okay, we knew it was a force, and we knew whatever it was, it had to be strong. So we called it the strong force, and we thought we were on top of this. Okay, and then there's another ancillary force that's doing the same kind of things in the nucleus of atoms. It was weaker, so we call it the weak force. We don't really get these forces. Not like we can do the experiments with gravity and electromagnetic force. These are a little bit, well, they're not as mysterious and make-believe as dark energy, because we actually see this happening, and it's the only way to explain it. But what I'm trying to say here is we don't really understand the strong force and the weak force. But these forces are only in the nucleus of an atom. And so, yeah, you were saying it's not the strong force, but I still don't see how a bunch of normal gases, this wouldn't even happen in a gravitational field like here on Earth, where you could actually get a gas cloud by its own gravity to contract, even with the help of our planet's gravity, and heat up enough to start fusion. long before that, the gas cloud would have to come back out. It would just, there isn't, I mean, someone could make some kind of a mathematical posit, but look at the equation. There's got to be a little fudge factor in there that's making this happen. Otherwise, we could do it here.
Intuitively, I mean, you acknowledge that the expansion of the gas is going to just want to expand, right? But there is a critical point called the Jeans condition where the strength of the gravity and of the mass of the gas overcomes that of the expansive force.
How do we know that there is that point? Have we seen it?
No, we don't.
No,
but
okay.
we do know that because
It's not like the triple point of solids, liquids, and gases. We can actually do experiments with this. Is
there must be a point simply because
Why must there be?
gravity overcomes the forces of expanding gas in a star.
Is it
As
because
is-
stars did collect by gravity that there must be a point where this can happen?
Well, surely you're not aware that the force of gravity is stronger than the force of heated expanding gases.
No, I'm not saying that. I'm saying that gravity can never be as strong as the
Then
force
how
of
do you
loose
explain
gases.
stars? How do you explain
What?
what holds together stars?
Well, okay, because that's different. You've got atoms that that don't have electron clouds. You've got if you in the extreme case you've got a neutron star where it's just packed neutrons. But in our star, you've got a plasma, free-flying electrons all around, and atomic nuclei that are actually hitting each other and fusing. That's a nuclear process. Nothing to do with standard normal atoms interacting with each other. I mean, it's a totally different thing. Now, if you actually have normal atoms and they're heating up, the average temperature of space is 3 Kelvin. Let's say these clouds are heating up to 100 Kelvin, you know. There's still many gases that are liquid and even solid at that temperature. You know, let's get up to 300 Kelvin. Let's get up to 400 Kelvin. But, you know, you got to get up to like 1,000,000 Kelvin to start the... But when you get up to like 400, 500 Kelvin, gases are going to push apart from each other. Your tire on your car would explode as the gases are trying to... And certainly the gravitational attraction isn't as strong as the steel radial belts trying to hold the gas in your tire. When we're talking about normal, conventional atoms and no nuclear processes are happening at all, no nuclear interactions are happening, we know from the laws of science it can't happen. So the gene triple point of this is, well, it's a mathematical construct. And by construct, I didn't mean proved by mathematics. I meant a mathematical work of art. A wonderful idea, but it is now outside of the realms of hard science. And I don't mind something that's soft science, but it remains a posit, a construct, and not something that can be tested at all, falsified or verified. So, you know, hey, it might even be true. And no disrespect to the gene guy, I'm sure he did wonderful mathematical equations on this thing, but it's not something that can ever be tested, not here. And actually, could we compress some gases and get them to do this? By gravity alone, we could maybe make them do this, but we would have to have forces besides gravity. Oh, okay.
By the same token, when the nuclear force operates at an order of Fermi, 10 to the minus 15th meter, when you go out to an angstrom for the atomic force, you know, that you have to be able to go down to that distance. Now, the Jeans criteria says that dPdr is equal to gm, you know, really it's density of m over r squared. So one is going as 1 over r squared, the other is going as 1 over r. And when it gets to a certain point, the gravity will take over, but it can't get to that point because there's no mechanism for it to overcome that barrier. And so...
So you're saying, like, before it would reach the critical point,
Yes.
The forces of gravity wouldn't be strong enough to
They would never be strong enough to reach. That's my theory of the Jeans theory.
Yes?
Yeah. As an educator myself, I'm aiming for a doctorate out of Penn State. take them apart and get down to the base, it becomes really frustrating because there's nothing there, to support it.
Yeah. Somebody asked the same thing of Marilyn Beausavant. As a non-scientist, how can I accept current scientific theories, for example, the wave nature of light, when so many theories of the past have later been proven to be incorrect? Is that kind of what you're asking?
A little bit bad. In fact, there's so much of that right now that just seems...
Now, Marilyn Beausavant says here, she said, I think it's wrong to teach creationism in the schools. So she does not a creationist like me. But I also think we must be careful not to teach theories as facts. And I gave you that quote before. But she says here, if you were a scientist, I think you should ask yourself the same question. Not long ago, I wrote about the Kansas State Board of Education's decision, which was 1999, to delete evolution from the state science standards. They didn't. They just called it change over time, and it was still in there. They just didn't call it evolution. It was a big court case and all that. I added that evolution is easy for both scientists and non-scientists to support. I'm going to say you can't prove it, but you might support it. But that the Big Bang Theory is different. So here she goes into critical thinking, doesn't mention critical thinking on evolution, but she does on the Big Bang. The theory holds that billions of years ago, everything in the universe was contained in an area smaller than the head of a pin, and that this minuscule speck of unbelievably dense and incredibly hot matter suddenly exploded violently. That sounds just plain nuts, right? But do you believe it? And if so, how do you support your belief that the entire cosmos was once smaller than a polka dot? With a strong line of reasoning, solid evidence, anything at all? If you cannot, welcome to the world of faith. You're accepting what you've been told by those you respect. And she says, lots of science, far too much is accepted on faith. So that's probably answered your question. It's science, unfortunately, has become some kind of a political debate and a political election with delegates and electoral votes and everything, and that's not how it was originally meant to be. That's not what the pure search for knowledge should be. It's about personalities and endowed chairmanships and National Science Foundation grants and book authoring deals and massive egos and reputations. What if someone who'd been teaching some theory for 30 years and the theory was disproven? What would they would fight for their very lives, especially if their ego was all they really thought gave value to their lives. People who are opposing changing any of the dogmas in science are often fighting for their self-esteem, for their reputations, for their careers, and for their very life's work. It would be really rough. People who believe the geosynclinal theory of mountain building before continental drift took on. I mean, Alfred Wegener proposed continental drift in like 1912, and he died in the 1940s. And then in the 1960s, lo and behold, the Glomar Challenger did a magnetic map of the ocean floor, and we saw these stripings that would have been predicted by continental drift. And all of the old geologists just had to give it up. I think it's unfortunately has nothing to do with the search for the truth. What you're talking about has to do with human personalities, and that does bother me a lot about science. And I think it bothers me in people's positions on lots of things, including on religion. There's dogma and hypocrisy in religion. There's dogma and hypocrisy among religionists. There's dogma and hypocrisy among scientists and in the world of science. And I'm afraid, since science is a human endeavor, it will always have these human failings and faults. However, the scientific method was designed to overcome those and give us a process that naturally winnowed out our problems with our human natures and make us more objective. Here we go. This is Max Planck of the Planck constant, a personal friend of Albert Einstein, who won the Nobel Prize in 1918. A new scientific truth does not triumph by convincing its opponents and making them see the light, but rather because its opponents eventually all die. And a new generation grows up that is familiar with the ideas from the beginning. I call this inertial thinking, named after the process of the property of matter, inertia. Inertial thinking, which resists any change in direction or motion unless acted upon by an outside force. And that outside force normally has to be a ton of a mountain of very heavy data that just says, okay, I got to give it up. And most people go to their grave holding on to the old construct, whatever it was. So this has no place in any venue of searching for truth. I personally have strong feelings, and I was talking with Larry about this before. I have troubles in the religious world and in the scientific world with people who are holding on to traditional ideas rather than a search for the truth. And Jesus Christ put a very high premium on truth. He said, the truth will make you free. The truth will make you free. And in truth is the only thing that should matter in science. Truth is the only thing that should matter in religion. You can keep yourself all happy by believing in things that don't exist if that's what you want to do. But that has nothing to do with what I would call pure spirituality or pure scientificality, too.
So both categories, it seems like there's an aversion to uncertainty. There's an aversion to recognizing the boundaries of our knowledge. In religion, we try to put God in a box and say, this is the way God is when we're talking about God's, if you talk about God as having eternal qualities and being metaphysical and that he has to reveal himself to us because it's outside of the physical and we can't measure him. So we try to sort of put boundaries around God to limit him to those concepts that we can hold to. But at the same time, in science, we try to put, boundaries to the entirety of creation in order to feel more comfortable instead of operating with the idea that, there are these ideas and we're trying to grasp that, but we haven't quite gotten to. But I would have to say, Madam Savant's probably right that we're limiting ourselves to the truth search by not recognizing the boundaries of, our own ignorance, our own, challenges yet. Because we have to know what we don't know in order to explore.
Yeah, the great theologian A.W. Tozer mentions what you're saying in his book, The Knowledge of the Holy. Philosophy and science have not always been friendly toward the idea of God, the reason being that they are dedicated to the task of accounting for things and are impatient with anything that refuses to give an account of itself. Because he's not just going to, he's going to knock theologians too here. Hold on. The philosopher and the scientist will admit that there is much that they do not know. But that is quite another thing from admitting there is something which they can never know, which indeed they have no technique for discovering. To admit that there is one who lies beyond us, who exists outside all of our categories, who will not be dismissed with a name, who will not appear before the bar of our reason, not submit to our curious inquiries. This requires a great deal of humility, more than most of us possess. So we save face by thinking God down to our level. This guy wrote this to Christians, okay? Tozer was a Christian theologian. To our level, or at least down to where we can manage him. Yet how he eludes us, for he is everywhere while he is nowhere. For where has to do with matter and space, and God is independent of both. He is unaffected by time or motion, is wholly self-dependent, and owes nothing to the worlds his hands have made. Okay, so that kind of explodes the image, and I was actually, Casey, making a point about Richard Dawkins not being all that good at philosophy and arguing and stuff like that, but I wholeheartedly agree with him. He said, I'm going to do my best Richard Dawkins here.
If there was a God, he would have to be so far and high above us that merely conceptualizing him would be madness.
If Dawkins ever becomes a religious believer, the dude is going to make an awesome, not hypocritical Christian. The one best thing I can say about Dawkins is the guy is not a hypocrite. He is consistent with everything he believes. He wrote an article about 5 years ago, and he said, I know it's not going to be very popular to say so, but Hitler really got it right, It's like the guy knew that, if one race, was more fit than the other and could manage to exterminate that race, that's actually legit as far as natural selection goes. You should be. It's a destiny. He sticks to his guns. The guy is not a hypocrite. I've never seen him contradict himself. I don't like some of the things he says, and I think a lot of things he says are not right. But he's not a hypocrite. And like I said, there are hypocrites in evolution science. I've heard them say things. Michael Shermer, I've caught him saying one thing out of one side of his mouth and the other thing out of the other side of his mouth. I even got a PowerPoint I made when he did that, so I got the proof. I caught him doing it. Because he's got an agenda, and he doesn't care whether he stays legit or not. Dawkins doesn't lie about where his beliefs lead him. But if he ever becomes a Christian, man, he'll actually say, you know what, God is boss, and you got no business trying to analyze him. You only got to do what he says. I'm praying for him to become a Christian. I really am. He'd make a great Saul of Tarsus sort of a